Hi, I'm Anna, and welcome back to the D1 Audible Cheat Sheets, where we conclude with Chapter 15. If Part A was about preparing wine to be stable, Part B is about the moment you commit. Packaging is the point of no return. Once it's sealed, your options collapse to almost nothing. If you misjudge oxygen, if you leave microbes behind, if your closure choice doesn't match the wine's needs, the bottle will still go out and it'll still carry your name. This is why, in professional wineries, finishing often requires a final chemical analysis and last minute adjustments. Alcohol, residual sugar, free SO2, and other key parameters get checked because those numbers predict risk. If you're making wine for a retailer or a private label, those numbers also define the contract. Consistency isn't just a quality tool, it's a business requirement. Then there's the thing the winemakers have become almost obsessed with in the last couple of decades: oxygen. Not oxygen as a villain, but oxygen as a variable that must be managed with precision. At packaging, oxygen can enter in multiple ways. Some is already dissolved in the wine, some sits in the headspace below the closure, and the headspace is often the biggest contributor. Some oxygen is contained in the closure material itself, and then there's the closure's oxygen transmission rate, the OTR, which determines how much oxygen can enter over time. Winemakers measure total package oxygen because shelf life depends on it. Too much oxygen, and you invite premature aging and oxidation, browning, loss of primary fruit, bruised apple characters, and a tired finish. Too little oxygen, and you can drift into reductive territory, especially under very tight seals, where sulfur compounds show up as onion, rubber, or rotten egg. It's never oxygen good or oxygen bad, it's oxygen appropriate. That's why finishing options include routine adjustments of SO2 before bottling. This is one of the most exam friendly sections of the chapter because it ties chemistry directly to style and stability. Winemakers check total and free SO2. Free matters because it contains the fraction that exists as molecular SO2, the most effective form for antimicrobial and antioxidant protection. And the right target level depends on style, pH, sweetness, and intended drinking window. Lower pH wines need less SO2 to be protected effectively. Sweet wines, because they're more microbially vulnerable, tend to need more protection. If dissolved oxygen is too high before bottling, winemakers can sparge the wine, flushing it with inert gas to strip oxygen out. And yes, sometimes winemakers deliberately add a small amount of CO2 to youthful whites and rosés for freshness, giving that barely there spritz that lifts the palate and makes the wine feel brighter. The key is that this is controlled, not accidental. Now we move to false because D1 expects you to link false to failures in process and then to prevention. Cloudiness and hazes often come from microbial growth due to poor hygiene or inadequate filtration. It can also come from protein instability in whites if fining was misjudged or overdone. Tartrate crystals are harmless but can alarm consumers. Re-fermentation in bottle is a stability failure, usually sugar plus remaining yeast. Cork taint is that moldy wet cardboard smell associated with TCA, plus the way it suppresses fruit and shortens finish. Oxidation is either process exposure, packaging failure, poor closure performance, or simply aging a wine not built for it. VA or volatile acidity comes from acetic acid bacteria and oxygen exposure, often where SO2 was inadequate. Reduction can be yeast stress under fermentation or extreme oxygen exclusion later, especially with very tight closures. Light strike is UV and certain visible wavelengths reacting with compounds to form sulfur off odors, and clear glass is the easiest victim. Brett, again, is the one that's hard to remove once it lives in a cellar. Which brings us to packaging formats. In most markets, glass still dominates because it's inert, inexpensive to manufacture, available in colors, and it's impermeable to oxygen, which makes it the best for wines intended to age. But glass is heavy and fragile. Heavy means carbon footprint in transport. Fragile means risk. And once opened, headspace oxygen accelerates oxidation quickly. Excuse me. Plastic, especially PET, is lightweight, tough, and cheaper to ship, but it must be lined with a barrier to reduce oxygen ingress, which means it's better for wines with limited shelf life and casual settings, not for cellaring. Bag in box is one of the most logical inventions in the wine world when you care about oxygen after opening. The bag collapses as wine is poured, limiting oxygen contact. It stores well, stacks well, and has a lower environmental impact. But the shelf life is limited. Oxygen ingress tends to happen at the tap, and the wine usually needs slightly higher SO2 and very low dissolved oxygen at packaging. It's a format built for early drinking, not romance. Bricks, like Tetra Pak, exclude oxygen and light well and perform strongly at lower price points, especially where price is a primary driver. They require expensive filling equipment, which is why producers often outsource. Pouches are similar to bag in box material in a different shape. Cans are light, robust, recyclable, and impermeable to oxygen once sealed, but they must be lined so the wine's acidity doesn't attack the aluminum. Canning is typically outsourced and currently most common for inexpensive to mid price wine aimed at immediate consumption. Then we get to closures. And closure choice is one of those topics where science and consumer philosophy psychology collide. Natural cork still holds the emotional high ground for many drinkers. It's renewable, flexible, and part of the ritual. But it comes with two historic problems: cork taint and variability in oxygen ingress. Even within the same lot, different corks can allow different aging trajectories. That risk has driven both innovation and competition. The cork industry has improved cleaning, including steam extraction, and introduced more rigorous quality control. Technical corks exist to reduce taint and standardize OTR. Agglomerated corks fit inexpensive early drinking wines. 1+1 corks combine agglomerate with natural cork discs. And diam style corks aim to be consistent and taint reduced with selectable OTRs. Synthetic closures, the so called plastic corks, avoid cork taint but historically allowed too much oxygen ingress for aging. Modern versions offer different OTRs, but they can also raise concerns about flavor scalping where plastic absorbs aroma molecules. Whether that's perceptible in real world drinking is still debated, but for D1, you need to understand that concept. Screw caps are a different ecosystem. They require bottle design changes and different equipment. Their seal depends on the liner. Tin liners are highly impermeable. Saran allows low oxygen ingress. Screwcap eliminates cork taint, is convenient, and in markets like Australia, New Zealand, and the UK, it's normal even for fine wine. In other markets, perception lags. A key technical point: a very tight screw cap seals can increase reduction risk. So, winemakers often adapt SO2 levels and oxygen management accordingly. Glass stoppers look premium and have a reusable feeling and elegant, but they require special bottles and are priced like top cork. They are a choice for premium and super premium positioning. Now, how packaging is done matters as much as what you choose. Modern bottling lines rinse, sterilize, and run like a controlled environment. Most large producers use sterile filtration immediately before bottling because it avoids applying heat that could prematurely age the wine. Heat treatments like flash pasteurization exist, but sterile filtration dominates for quality preservation. Either way, the bottling line must be sanitized so you don't do everything right and then contaminate the wine at the last meter. Bag and box, bricks, and cans require dedicated filling lines and meticulous oxygen management. Bags often go under vacuum before filling. Bricks use sterile enclosures and ultraviolet to sterilize packaging material. Canning is usually outsourced to specialists. Post bottling maturation is where all these choices reveal their consequences. Wines built on primary fruit usually don't benefit from time, they lose freshness. But some wines truly need time. Vintage port, premium German Rieslings, classified growth Bordeaux, certain PDOs even mandate minimum bottle age before release. Bottle aging at the winery costs money because storage space, climate control, insurance, and delayed cash flow all add up. For aging, the ideal storage conditions are stable and cool, roughly 10 to 15 degrees Celsius, dark, with constant humidity. If sealed with cork, bottles stored on their sides help keep corks moist and maintain seal integrity. Finally, chapter 15 ends like a grown up. It acknowledges that winemaking is not just art and science, it's systems. Hygiene is foundational. Cleaning, sanitation, and sterilization are distinct levels of control. Modern wineries are designed for cleanability. Non porous floors, drainage, accessible equipment. Wood is always the tricky place because pores can harbor microbes. Quality control is the day to day practice of making sure a product is consistent and safe. Quality assurance is the full management system and documentation that proves you've taken reasonable precautions and can defend your process legally and commercially. HACCP is the mindset of identifying hazards, rating severity, preventing them, and creating corrective actions. ISO certification is the external audit layer often demanded by retailers. Traceability is the final safety net. Lot numbers allow wineries to trace problems back to specific batches, additives, processes, and vineyard sources. Larger wineries keep retained samples to compare and investigate complaints. That's not paranoia, that's professional responsibility. And then we finish with transport because transport is not neutral. Bottling at the winery gives the producer total control, but shipping glass is heavy, carbon intensive, and vulnerable to temperature swings. Bulk shipping has grown rapidly for inexpensive to mid price wines because it's more efficient. More wine per container, lower carbon footprint, better thermal inertia, and the chance to adjust SO2 and bottle closer to the market, extending shelf life because the clock starts at bottling. Flexi tanks are common single use bags inside containers. ISO tanks are reusable stainless steel options. But bulk shipping changes economics and jobs, shifting value from producer countries towards bottling markets near consumers. So, chapter 15 is not the end, it's the moment wine becomes a product with a guarantee of stability, a guarantee of consistency, a guarantee that what the winemaker intended survives the messy real world between cellar and glass. I hope you enjoyed this and this helps with your prep. I'll see you at the next episode.